Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers AQA Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Question 2, circle the largest number. I'm going to rewrite each of these to three significant figures. So 0.5 with the dot on, that's a reoccurring decimal, isn't it? So that is 0.55, well, it'd be 55, and if I rounded off to three significant figures, then this would round up and it would become 556, wouldn't it? Okay, so just round it off to three significant figures so I can compare it. This one would be 0.550 to three significant figures. This one can just stay the same. And this one would be 0.545, well, it would repeat 45. So then if I round that off after three significant figures, then I'm going to be rounding down. So that one is going to stay as 545. Okay, so now I've got them done like that, then I can start comparing them. The first two digits are the same for all of them, so no change there. And then I've got a couple with 4s on the front and a couple with 5s on the front. So obviously the 4s are smaller, so they're out. Then finally I've got something with a 6 here and a 0 here. So it's this one, isn't it? That's the largest of the two. Hector can run 400 meters in 66 seconds. Use this information to show that he could run 5 kilometers in less than 14 minutes. So he can run 400 meters in 66 seconds. So what is his speed that he's running at then? We've been given this, which is distance traveled, and this, which is time taken. And I know a relationship between distance, speed, and time. Do you? It's a handy little little triangle. Distance, speed, time. Those letters are there alphabetically. That helps you work out what the equation is that links those three quantities. Now we want speed, which is down here, look, and that tells me that it's the other two divided by each other. So speed, or average speed, is distance traveled divided by time taken. So that would be 400 meters in 66 seconds. So calculator, what's 400 divided by 66? That comes out to be 6.06. Reoccurring 060606. I'm just going to round it off to 6.06. So that is 6.06 meters per second, isn't it? That's the speed they're traveling in. So if we know that that's the speed, and I'm going to be running at 5 kilometers, how long is it going to take me to run 5 kilometers at 6.06 meters per second? So then I want to find out time. So coming back to my triangle, if I covered up time, then it would be distance over speed, isn't it? So that's my next calculation I'm going to have to do. So time is equal to distance travelled over average speed. Okay, so now the distance is 5 kilometers. My speed though is in meters per second, so I'm going to convert that 5 kilometers to 5,000 meters and then divide it by 6.06. What's that going to give me? Well, I've got the last calculated value still as the answer. I'm going to use the full calculated value by using the answer key. So 5,000 divided by answer, that's given me 825. What unit is that going to be in? I had meters and I divided it by meters per second, so that is going to be seconds. 825 seconds. Now, what's that in minutes then? To convert minutes, to convert seconds into minutes, I'm going to divide by 60, aren't I? There's 60 seconds in a minute. So 825 divided by 60 would be what? 13.75 mins. Now that's a decimal, isn't it? So what I want to do, if it was any other sort of questions, maybe convert into minutes and seconds. But here I just need to show that it's less than 14 minutes, which I've kind of done already. So I'm just going to finish off with that then. So I can therefore say, Hector could run it in 13.75 mins. Right, and it says Hector tries to run 5 kilometers in less than 14 minutes. Give one reason why he might not be able to achieve this. Well, fairly obviously that 5 kilometers is a lot further than 400 meters, and you kind of run out of energy after a while, don't you? You know, you can't run at a sprinting speed for 5 kilometers. You've got to go at a slower pace. So what I would say here is that Hector may tire and slow down. The diagram shows the results to the nearest percentage of a survey of 1,000 motorists. Driverless cars. Good idea, 20% think it is. Bad idea, 34% think it is. And not sure, 45% think it is. Interestingly, they don't add up to 100%, do they? Right, work out the largest possible number of motorists who thought driverless cars were a good idea. So actually, this is to the nearest percentage. It's a limits of accuracy question, isn't it? So if it was 20% to the nearest percentage, it means it's been rounded off to 20. Now, the next percentage up would be 21, and the next percentage down would be 19. So the ones that round to 20 are the ones that are halfway between those two. So the limits are going to be 19.5 and 20.5. They're the ones that round to 20 to the nearest percentage. So work out the largest possible number of motorists who thought driverless cars were a good idea. The largest possible is going to be the larger of those percentages then, isn't it? So I'm going to be using this upper limit then, 20.5, to calculate. Now obviously 20.5 you round up to the next value up, 21, but it still is the boundary and is still the one we calculate with. So largest possible is going to be 1,000 times by 20.5%, which is 1,000 as a multiplier. That's 0.205, isn't it? So that is 205. Now, strictly speaking, if it was 205 exactly, that would round up to 21% and not down to 20%. So I'm going to subtract 1 from that. and write my answer as 204, because I know that definitely will round down to 20%. And the diagram shows a square-based pyramid and a sphere. The pyramid has a base length of 12.3 centimeters and a perpendicular height of 15.7 centimeters, and the sphere has a radius r. The pyramid and the sphere have the same volume. Work out the radius of the sphere. You must show your working. Okay, we've been given the formula for pyramids and spheres, which is handy, so we don't have to remember them. Right, okay, so we know that these two shapes have the same volume, so these two things are equal in volume. Now we've got no measurements on the sphere, and we need to find out what r is. So we're going to deal with the pyramid first. Okay, so we're going to work out the volume of the pyramid, and then we're going to work backwards with the sphere formula to find the radius. Okay, so let's crack on with that then. So the volume of the pyramid is, what's that then? So the formula is down here. It's 1/3 times the area of the base times the perpendicular height. Okay, so 1/3 times area of the base times the height. Now, this particular pyramid is a square-based pyramid, so the area of the base then is going to be this area here, whatever that is, and because it's a square, it's quite easy to find. That's just going to be 1/3 of the area of the base then is going to be 12.3 times 12.3, isn't it? 12.3 squared, and then the height is 15.7. 15.7. Okay, so throwing that into the calculator, we should be able to find out the volume fairly easily. So 1/3, I'm just going to divide everything by 3 at the end, I think. So 12.3 squared times 15.7 divided by 3, and that comes out to be 791.75 equals 791.751. Okay, and then what we're going to do now, so now we need to work out the volume, well, the radius of the sphere, don't we? So we know that the volume of the sphere is equal to 4/3 pi r cubed. Okay, so subbing in what we know that then that is 791.751 there, and we want to get r by itself, don't we, really? So we're going to have to rearrange this to make r the subject. Okay, so I'm going to multiply through by 3 and divide through by 4 pi basically. So I'm going to divide by 4 pi and times by 3, aren't I? Okay, and that will cancel those all out on the left and the right, and then I'll get 791.751 over 4 pi times 3 then, aren't I? Okay, so the 3 comes up and the 4 pi goes down, and that is equal to r cubed. Okay, and then so to find r, we're going to have to cube root that then, aren't I? If I cube root both sides, then I'll get the cube root of all of that. Okay, r is the cube root of 791.751 times 3 divided by 4 pi, all cube rooted. Right, so let's type that in. So I'm going to use the root sign first. So cube root, shift, there it is. Shift cube root, and then I'm going to use the fraction key. 791, well, it's actually my answer, so I'm just going to press answer, times by 3, and on the bottom I'm going to have 4 pi. Okay, what's that then? That's 5.7389. I'm going to round it off to 3 significant figures. I'm going to say r is 5.74. R equals 5.74. Unit centimeters. So 5.74 final answer. The graph shows the speed of a tram as it travels from the library to the town hall. And we've got a little diagram underneath. It's a speed time graph, isn't it? So we've got speed in meters per second up the side, and I assume that's time along the bottom in seconds. Calculate the deceleration of the tram as it approaches the town hall. Okay, well, I assume that this upward part of the journey, that's it going from the library to the town hall. So you can see it's accelerating for all that period, and then it kind of reaches a peak speed, and then for the second part of the journey it's decelerating at a constant rate until it reaches a stop here. Okay, so calculate the deceleration part of the journey. Now on a speed time graph, acceleration is equal to the gradient of the line, isn't it? Now gradient is change in y divided by change in x, isn't it? In this case it's the change in the speed divided by the change in the time. So the speed changes from 6 down to 0 then, isn't it? So that's a change of -6 actually, because it's decreased. And the change in y is this distance from here to here, 85 subtract 65. Okay, which has got a difference of 20. So the acceleration is -6 over 20, which is -3 over 10, which is -0.3, equals -0.3. So if the acceleration is -0.3, then the deceleration is just 0.3, isn't it? Okay, because deceleration is how quickly it's slowing down, whereas acceleration is how quickly it's speeding up. So a negative acceleration means a positive deceleration. Right, part B. Calculate the distance travelled by the tram between the library and the town hall. Now, distance travelled is area under the speed time graph. Okay, and in this case we've got two distinct areas, haven't we? We've got this one here, which is a triangle, and we've got a separate triangle here. Okay, so we've got two triangles. Another way of looking at it is those two triangles make one big triangle, don't they? So you can use the baseline all the way across from there to there, which is 85, and the height of the triangle is 6. So I'm just going to work it out as one big triangle, half baseline of 85 and a height of 6. So half 6 is 3 lots of 85, 240, 255. 255, and what's the units? It's in meters of second and seconds, so that's going to have to be meters then, isn't it? 255 meters. Part C says, what was the maximum speed of the tram as it travelled between the library and the town hall? Give your answers in kilometers per hour. Okay, so let's have another look at the graph. You can see from the graph its maximum speed is going to be that tip point on the graph, the highest point on the graph, isn't it? And we're already told what that is. That's 6 meters per second. So this question is just really about conversion, isn't it? We need to convert that 6 meters per second into kilometers per hour. Okay, so maximum speed is equal to 6 meters per second. So now we need to convert meters per second into kilometers per hour. Okay, now there are 1000 meters in a kilometer. There are 60 seconds in 1 minute, and we've got 60 minutes in 1 hour, haven't we? So if we're going to convert this from meters per second into kilometers per hour, we're going to have to take that 6, divide it by 1000 to go from meters into kilometers. We're also going to have to multiply it by 60 to go from seconds to minutes, and then multiply it by another 60 to go from minutes into hours. So what's that? Reaching for the trusty calculator. 6 times 60 times 60 divided by 1000. That comes out to be 21.6. 21.6 kilometers per hour. Does that sound reasonable? Yeah, it's not super fast, is it? It's probably what you'd expect a bus to be traveling at. Aisha recorded the heights in centimetres of some girls. She used her results to work out the information in the table. Least height was 142, lower quartile was 154, interquartile range was 70, median was 162, range is 40. Aisha drew this box plot for the information in the table. The box plot is not fully correct. Write down 2 things that Aisha should do to make the box plot fully correct. Okay. Right, so let's just go through and check what she's done. Thing 1, she has drawn a scale. That's normally what you start with. Is that correct? It's going up in tens. There's no gaps. It's all looking good. She's marked the name of the scale, so that's good. That's the first thing you should do. Right, then what? She's written on the least height, which is 142. Is that correct? That's the least height there. That does look correct. Okay, that is at 142. The lower quartile, that should be at 154. That also seems correct. This is the lower quartile. It's the left-hand side of your box. Interquartile range is 17. So there isn't anything for interquartile range. The interquartile range is the width of the box. So that should tell you that the upper quartile, which is called Q3, that's going to be the lower quartile, 154 plus 17. So 154 plus 17, that's 164, 171, isn't it? So is the upper quartile at 171? No, it's not. It's at 172. Okay, so the first error is that she has got the upper quartile in the wrong place. So my first thing is upper quartile Q3 should be at 154 plus 17 equals 171 centimeters. Okay, right, so then that's that. Now, next thing, median at 162. You have gone cropper again there, haven't you, Aisha? So she's drawn it at 161. So that's the second thing. So median should be at 162 centimeters and not 161 centimeters as she's drawn it. Okay. Now, what's the last thing she did here? Range is 40 centimeters. Is that correct? The greatest height then should be at 142. The least height plus the range, that's 182. Now, actually, that is correct. Ran out of colors. Maybe use yellow again. So then the greatest height should be 182, which is correct. That one is all right. Okay, so we found all the errors. It's the median, and it was the upper quartile that was wrong. The diagram shows a cuboid and its diagonal, and the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem. So when you move from 2 to 3 dimensions, all you got to do is add in your extra length then to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where A is 8, B is 3, and C is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of A squared, 8 squared, plus B squared, 3 squared, plus C squared, 2 squared. So, job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So length is going to be equal to the root of a squared plus b is going to be 2a, so 2a squared, and c is going to be 2a squared, like that. So how many a squareds have we got then? I've got a squared plus 4a squared plus 4a squared, which gives me 9a squared, and the square root of 9a squared, well, the square root of 9 is 3, and the square root of a squared is a. So it gives me 3a. And obviously when you square root, you often get two results, positive and negative, but in this case there is only one solution that's valid, isn't it? It's 3a. Question 10. Eva writes 4 squared times 4 squared times 4 squared equals 4 to the power of 2 times 2 times 2, which is 4 to the 8. What is wrong with her method? Eva. I hope you haven't got your exam in a few weeks' time. Now obviously when you've got numbers with the same base and you multiply them together, you add the indices, you don't multiply them. So give the correct answer. Well, it should be 4 squared times 4 squared times 4 squared is equal to 4 to the power of 2 plus 2 plus 2, which is 4 to the power of 6. Question 11. A sequence is defined by the rule un plus 1 is equal to 5 lots of un minus 15. If u3 is 6, calculate u5. Okay. So what we've got here is what we call a term-to-term rule defined algebraically. So un plus 1 is 5 lots of un. So the next term, un plus 1, is 5 lots of the previous term minus 15. So this is kind of given as a term-to-term rule rather than a position-to-term rule. Okay. So if u3 is equal to 6, then u4 is going to be 5 lots of u3 minus 15. The next term, u4, is 5 lots of the previous term, u3 minus 15. So if u3 was 6, that's going to be 5 lots of 6 minus 15. 5 6s are 30, take away 15, that is 15. So u4 must be 15, and u5, the fifth term, must be 5 lots of u4, the fourth term, minus 15. And we've just worked out that u4 must be 15, so that's 5 lots of 15 minus 15. So 5 15s minus 15 is 4 15s, so that is 4 lots of 15 is 60, isn't it? Okay, so u5 is going to have to be 60. Right, now u2, we're going to have to do a bit of working backwards here. We know that what u3 is, so if I use using un plus 1 is equal to 5 un minus 15. So I want to work backwards and find what u2 is from u3. So u3 is going to be 5 lots of u2 minus 15, isn't it? Now I know u3, it was given 6. So 6 is equal to 5 lots of u2 minus 15. I'm going to have to rearrange this, make u2 the subject, okay, so I can find out what it is. So add in 15 to both sides. Just going to kind of work as if it is a normal equation to solve. So that's going to cancel with that. It's going to leave me with 21 is equal to 5 lots of u2, and then dividing both sides by 5. It's going to cancel, leave me u2. So u2 is 21 over 5 then, isn't it? u2 is, what's 21 divided by 5? 21 divided by 5. 4.2 apparently. So u2 is 4.2. 4.2. Part B says, Trevor says if u1 equals 3.75, then u100 must be 3.75. Show that Trevor is correct. Okay. Well, we know that un plus 1 is 5 lots of un minus 15. So what happens then if u1 is 3.75, then U2 then is going to be 5 lots of 3.75 minus 15 then, isn't it? Okay, and what's that? 5 times 3.75 minus 15. That gives me 3.75 again. Okay, so you can see that when I sub 3.75 into this expression, I'm going to get 3.75 out. So that means U3 is going to be 3.75 and U4 is going to be 3.75. So pretty much anything, U anything is going to be 3.75 then, isn't it? Okay, and it just stops it being 3.75 the whole time. Okay, so we've kind of done that. We've shown that it's always 3.75. The straight line passes through the point 8, 1 and is perpendicular to the line for y equals 4x minus 2. Find the equation of the line given your answer in the form of y equals mx plus c. Okay, so from the line y equals 4x minus 2, then our gradient, which I'm going to call m1, is 4 then, isn't it? Okay, so our line is perpendicular. In other words, m2, our gradient, is going to be minus 1 over m1, the negative reciprocal of the original gradient, so that's going to be minus a quarter. Okay, so I've got the gradient already of my new line. All I need to do now is to find c, the intercept, don't I? Okay, and to do that, I'm going to use this point up here that it passes through. Okay, so first off, I'm going to say equation is of form y equals minus a quarter of x plus c. So I've kind of created a partial equation by subbing in the m value I know of minus a quarter here, and that just leaves me the c value to find, and I'm going to use the point to find it now. So line passes through the point 8, 1. So subbing those values into the line, that means this is 8 is the x value and y is the 1 is the y value. So subbing in the y equals 1, and that is equal to minus a quarter lot of x, which is 8 plus c. And then what's that then? So minus a quarter lots of 8, that's minus 2. So I've got 1 equals minus 2 plus c. Adding 2 to both sides, you can see that c is equal to 3 then, isn't it? Okay. So now I've got the full equation. Therefore, equation is y equals a minus a quarter of x plus 3. The amount spent on clothes by 40 boys and 40 girls in 1 month was recorded. The table shows information about the amount spent by the boys. Okay, and I can already tell from the table, this is a group frequency table. So again, group frequency, they've got the midpoint mark, so I'm guessing they're going to ask me to find that estimated mean. The mean for the girls was £35. Estimate the mean for the girls as a percentage of the mean for the boys. Okay, so obviously the first thing I need to do is find what the mean for the boys is. So as I said, the table is already set up for it. To find the mean from a group frequency table, or estimate the mean, the first thing you've got to do is work out the midpoints of each of the groups or classes. That's because you don't know, out of these, for instance, these 22 boys here, you know that they scored between 0 and 20, but you don't know the precise value, do you, of what they've got now, because the data's been grouped. So we use 10 halfway between them. 0 plus 20 divided by 2 is 10, as an estimate of what those 22 boys spent. Okay, so going down the list and working out the other endpoints, the midpoints. So 20 plus 40 is 60, divided by 2 is 30. 40 plus 60 is 100, divided by 2 is 50. And 60 plus 80 is 140, divided by 2 is 70. Okay, so they're the midpoints that I'm going to be using. So if I'm saying that 22 boys spent well, I'm estimating £10 each, then between them, if I multiply those together, 22 times 10 is 220. Okay, I'm going to do that for each of my other values. 30 times 9, was that 270? 50 times 6 is 300. And 70 times 3 is, what's that, 210? Okay, adding that up, you can use your calculator if you like, but often it's easier just to do it in your head. So that's 0, and then 2, 7, and 1 is 0, carry 1, and I've got 2, 4, 7, 8, 9, 10. So that adds up to 1,000. Okay. You might want to double check it on your calculator, but I think that's right. So then the estimated mean then for the boys is going to be sigma fx which is this amount here, isn't it? The sum of the frequencies times their values, which is 1,000, divided by sigma f, which is this value here, the total sum of the frequencies. So 1,000 divided by 40. So what's that? I think it's 25, but let me just double check. 1,000 divided by 40, 25, yeah. Okay, so the estimated mean for the boys is 25. The mean for the girls was 35. Estimate the mean for the girls as a percentage of the mean for the boys. So if you're expressing one number as a percentage of the other, then the number that you are talking about first is the top number, and the number you're talking about second is the bottom number. So then the percentage, it doesn't look quite right here because it's a big one on the top, is going to be the mean for the girls, which is 35, divided by the mean for the boys, which is 25, and they're going to have to turn that into a percentage. Okay, so what's that then? So 35 divided by 25, that gives me 1.4, and times 100 is 140%. Okay, so the mean of the girls as a percentage of the mean of the boys is 140%. Oops, 140. A, B, and C are different prime numbers less than 20. And we're told that A equals the square root of 4B plus C. Work out two possible sets of values of A, B, and C. Okay, so we've got some puzzle pieces that we need to fit together to in a certain way. Let's first write down what all the primes are between, well, less than 20. So the smallest prime number is 2, then 3, 5, 7, not 9, 11, 13, not 15, 17, and 19. So I've got 1, 2, 3, 4, 5, 6, 7, 8 to choose from. So these are my primes. Now, I need to then pick 3 of these so they fit into that expression. A equals 4B plus C all square rooted. And that's going to have to give me another prime. Now, there are lots of possible combinations of 3 things from 8 things. So let's just see if we can think it through a little bit and make the choices a little bit easier for us. Now, we're going to have to take the value of B and times it by 4. So I imagine we're going to have to pick our values of B from the kind of lower end of the group. Otherwise, if we multiply them, 17 or 19 by 4, our number's going to get too big, I think. So I'm going to try picking my numbers from B at this end. Now, once we multiply it by 4 and add on C, we're square rooting. So we're aiming to get a square number, aren't we? We can pick a value of B, times it by 4, and add on one of the other numbers, and we're aiming to get a square number. So what are the square numbers? So squares. So we're aiming for 1 or 4 or 9 or 16 or 25 or 36 or 49 and so on. Remember though that a needs to be a prime number too, so I can't just have any square, it has to be of a square of a prime number. So not that one. 2 squared is, yeah, 3 squared, 4 squared, not that one. 5 squared is okay. 6 squared, not that one. 7 squared. 9 squared wouldn't be, the next one would be 121 if we're going to get that big. Okay, so let's try a small value of b to start with. Let's try b is 2. So 4 lots of 2 is 8. Now can we pick another prime number to add to 8 in order to get one of our squares that we're looking for? Okay, so let's go through. 8 plus 3 would be 11. No. 8 plus 5 would be 13. That doesn't work. 8 plus 7 is 15. Nope. 8 plus 11 is 19. 8 plus 13 is 21. 8 plus 17 is 25. Now that is one of our options. So 8 plus 17 is 25. And that would be, when I square root it, 25 square root would be 5. So that's one possible solution, isn't it? So that's b is equal to 2. C was equal to 17 and a is 5. So let's write that one in. Set 1, a is 5, b is 2, c is 17. Okay, so we've got one set done. Need to try it again and find another set. So let's try the next possible number. So try b is, let's try another small b. Let's try 3. So again, 4 lots of 3 would be 12. Now can I add another prime number on to get one of my square target ones that I'm looking for? So add in 2 would be 14. That doesn't work. Add in 5 would be 17. That doesn't work. Add in 7 would be 19. Nope. Add in 11 would be 23. Add in 13, that'd be 25 again, wouldn't it? So 4 times 3 plus 13 is 12 plus 13 is 15, is 25 again, and square root of that is 5. So again here b is 3, c is 13, making a 5. Now it doesn't matter that I'm repeating a twice, these are still two sets of results. So a is 5, b is 3, c is 13. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay. Now, the most popular way for this to be taught, I believe, is looking at second differences and using a kind of a convoluted way of piecing those two together. So the second differences here, for instance, are going to be 11, 21 take away 38 is 17, 38 taken away from 61, that is 23, and 61 take away from 90, that is 29. Okay, and then so that's what we call the first differences. The second differences are the differences of the differences. So you can see that's 6, 6, and 6. Okay, so normally when when people are taught how to do this, they're taught to find the second difference, take that value of 6 and halve it, and then that is going to give you your n term, 3n squared. And then you have to work out the rest. You have to kind of then work that out and take it away and all that sort of palaver. But actually there's a different way that you can do it that I want to show you. Well, maybe let's just finish this method off first, and then I'll show the alternative way of doing it, which I think is nicer. So 3n squared. So if n is, remember this is when n is 1, n is 2, n is 3, n is 4, n is 5. Okay, so this sequence, if n is 1, 3n squared would be 1 squared times 3. It should be 3. When n is 2, 2 squared is 4 times 3 is 12. When n is 3, 3 squared is 9 times 3 is 27. And then 4, n squared is 16 times 3, 32, 48. and then 5 is 25 times 3 is 75. So then you work out the differences between your original sequence and this sequence for 3n squared. So what's that then? So the difference is 10 take away 3 is 7, 21 take away 12 is 9, 38 take away 27 is 11, 61 take away 48 is 13, and 9 take away 75, that is 15. Okay, so now what we've got left with, I hope you can see, is a linear sequence. So this has got a common difference this time. It goes up in twos, 2, 2, 2, 2, which means it's got to do with 2n. Okay, but it's not quite 2n, is it? Because 2n would be 2, 4, 6, 8, 10, and we've got 7, 9, 11, 13, 15, and that is 5 more than 2n. Okay, so then we combine these 3 bits together to work out that the nth term then of this quadratic, therefore nth term is 3n squared plus 2n plus 5. Okay, so now the reason I'm not so fond of this method is that, you know, why 3n squared minus, do you even know why you have to halve it there? It's just kind of learning a way of doing something. You don't really understand why it is what it is. Okay, well, that's the reason why I don't particularly like it. So we're basically teaching students how to do something. We're not teaching them why. When we're teaching this method, they rarely understand why you have to take the 6n, the common difference and halve it, and that gives you 3n squared. They don't really make the connection. So I tend to teach it a different way. I use it with the general forms of a quadratic. So if it's a quadratic sequence, then the general form of a quadratic is an squared plus bn plus c, isn't it? That's the general form of the quadratic, okay, where a, b, and c are some constants. Okay, now when n is 1, that's the first term of our sequence, isn't it? So when n is 1, then an squared plus bn plus c, I'm going to have 1 squared times a, that's a, plus 1 lot of b, which is b plus c. Okay, and I know that that is equal to the first term of my sequence. It's actually equal to 10. Okay, now when n is 2, then an squared plus bn plus c, an squared, take n, 2, and square it, 4. I'm going to get 4a plus bn, which is 2b plus c. That is equal to my second term. That is equal to 21. Okay, and then when n is 3, n squared is 9, so that would be 9a plus 3b plus c, and that is equal to our third term, which is 38. So what we do instead with this, we kind of, and that's, you just kind of stop there. What we're doing is we're forming 3 simultaneous equations in a, b, and c, which we can then go on and solve simultaneously. Okay, now you might think, oh, simultaneous equations is horrid. Why on earth would we do it this way? This is really complicated. But actually, this bit here is the same no matter what sequence, quadratic sequence you're given. You always get this. So the only thing that you have to do is kind of bolt on your extra terms that you've been given from the actual sequence to form your equations. And then the technique becomes very similar. So after you've done a few this way, it comes really, really easy. Okay, so I've got 3 equations in 3 unknowns, a, b, and c, which I'm going to go on and solve. So the first thing I'm going to do is going to take equation 2, and I'm going to subtract equation 1. So equation 2, this one, subtract equation 1, which is this one. So what's 4a plus 2b plus c if I take away a plus b plus c? So kind of taking those away, I'm going to get 3a plus b, and the c's are going to cancel, so I'm going to get 3a plus b, and that is going to be equal to 21 take away 10, and 21 take away 10 is 11. Okay, and then I'm going to do the same thing. I'm going to do equation 3 take away equation 2, so then I've got equation 3 is this one, equation 2 is the yellow one. So taking the blue one, yellow one away from the blue one. So then 9a take away 4a is 5a, and 3b take away b is b, and 38 take away 21 is 17. Okay, so now I'm left now with two equations in two unknowns. Okay, so that's my second step. And now what we're going to do is we're going to take one of those away from the other. So that's going to be in my equation 4 and my equation 5. And now I'm just going to take 4 away from 5. So equation 5 take away equation 4. What's that then? So equation 5 then is this one. Equation 4 is this one. So if I'm taking equation 5 and I'm subtracting equation 4, what do I get? That's going to give me 2a is equal to 6. So a is 3. Once I know a, I can then sub it back into one of either 4 or 5 here. So 3a plus b is equal to 11. So 3 lots of 3 is 9. 9 plus what is 11? That tells me b is 2. Okay, and once I know b, then I can sub all those back into the first equation. A plus b plus c is 10. So a plus b is 5. And then what do I have to add on it to get 10? It must be 5, so c is 5. Okay, so they're my solutions. A is 3, b is 2, and c is 5. Then going back to our original form, a squared plus b, an squared plus bn plus c, just got to sub those values in. Therefore, nth term is equal to 3n squared plus 2n plus 5. Okay, so this draws on your knowledge of solving simultaneous equations. You might think, ugh, that looks hideous, I don't want to do it that way. But I would recommend giving it a go, because it's always the same. When you're doing this, no matter what quadratic you're doing, you'll find that 90% of the method is the same for every question, and you just get quite good at doing it. Okay, so try it. I'm not saying you have to do it this way, but I'm saying I think it's a better method, and students who do learn it this way tend to do quite well at it. So yeah, give it a go or not. Sophia is competing in a long jump competition. Her first jump is 5.25 meters. Her best jump is 8% more than this. However, her best jump is 10% lower than the winning jump. Work out the length of the winning jump. So let's just try and visualize that. I've got a 5.25 was her first jump. Her best jump was 8% above that. But as good as that one was, it was 10% less than the winning jump. So that was her best, and this was the winner. Okay, so let's work out her best jump first off. So best is going to be, well, it's a percentage increase, isn't it? So using our triangle final original multiplier, our final is what we're trying to get. Our original is 5.25, and our multiplier is, well, it's 100% plus 8%, which is 108%, which is 1.08 as a multiplier. So our final is equal to our original times our multiplier. In this case, the original was 5.25 times a multiplier of 1.08, and that gives me 5.25 times 1.08 gives me 5.67. So 5.67 is a very best jump. Okay, but the winning jump, well, this 5.67 is 10% lower than the original amount. So the winning amount is, well, the winning amount, subtract 10% is 5.67. So I actually want to do a reverse percentage here. So for the winning one, our final is 5.67. It's her best one. Our original is what we're trying to find, and the multiplier is going to be 100% less 10%, which is 90%, which is 0.90 as a multiplier. So using again the triangle final original multiplier, this time we are looking for the original, and we're going to use final divided by multiplier to find it. So that is 5.67 divided by 0.90, which is 6.3 meters, so 6 meters and 30 centimeters. That's a long jump. She's nowhere near it. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now notice that this 8 here and this 8 here are the same, so the number of shares for girls is the same, and the boys has gone from 6 to 5, so it's reduced by 1. So overall we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we'll find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. Question 19. 2 cylinders A and B are mathematically similar. Cylinder A has volume of 2,400 cubic centimeters and a height of 12 centimeters, and cylinder B has a volume of 750 centimeters cubed. Find the height of cylinder B. Give your answer correct to an appropriate degree of accuracy. Again, we've got a shape and space question and no diagram. So for me, first thing I'm going to do is quickly sketch what I've got. Okay, so I've got big cylinder equals cylinder, okay, which are mathematically similar. I know that this one is 2400 and this one is 750, and this one has a height of 12, and this one is got a height that I'm trying to find, so I'm going to call it H. Okay, so I've got my 2 diagrams. Okay, now when you've got 2 mathematically similar shapes, then the ratio of their lengths and areas and volumes are all related, aren't they? So the ratio of their lengths, let's say it was x to y, then the ratio of their areas is going to be x squared to y squared, and the ratio of their volumes is going to be x cubed to y cubed. Okay, so we've got Well, we know the ratio of their volumes because we've got the values we've got there. We've got 2,400 and we've got 750. Okay, so if we cube root both those numbers, we should be able to find the ratio of their lengths. Now let's just make this a little bit easy to calculate with. If we divide both sides by 750, then I make this second one 1, don't I? So 2,400 divided by 750, according to my calculator, is 3.2. Okay, so the ratio of their volumes is 3.2 to 1. Okay, so that means that the ratio of their lengths is going to be the cube root of 3.2 to 1, isn't it? So cube root of 3.2 to 1. Cube root of 1 is just 1. So the cube root of 3.2, again according to my calculator, is 1.47 to 1. I'm just going to keep the full calculator display value for now though, because I need to use that. This is going to be the length, isn't it? The ratio of their lengths. It's going to be 1.47 to 1. So if I then take 12 and I divide it by our cube root of 3.2, I should be able to find the height of our second can then. Okay, our second cylinder. So 12 divided by my previous answer comes out to be 8.14. Okay, so what would be an appropriate degree of accuracy? These numbers up here are quoted to 2 significant figures, each of them, aren't they? So I'm going to round this one off to 2 significant figures as well. I'm going to say that that is 12 to 8.1. Okay, so my height then is 8.1 to an appropriate degree of accuracy, 2 significant figures, the same as the other in the question. Lucy makes 5-digit number cards using all of these cards: 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay, so let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit, and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1, which is 72 choices. In question 22, we are given a triangle. We've been given a couple of the angles and a side, and we need to find side Y. Now, clearly this is a non-right angled trigonometry question because we've got sides and angles and we want to find one of the sides. Now we know 2 rules that we might apply in these sort of situations, and that is the sine rule and the cosine rule. Now we need to work out which one we can apply here. Now the cosine rule tends to be about 3 sides and an angle. So either you know 3 sides and you want to find an angle, or you've been given an angle and 2 sides and you want to find the 3rd side. So that's the cosine rule. Now that isn't what we've got here. Here we've been given this angle and this side and this angle, and we want to find this side. Now the sine rule is about opposites, so where you've got 2 pairs of opposites like this, we can apply the sine rule. Now the sine rule says A over sine A equals B over sine B equals C over sine C as well. We don't need that much though. And then we can sub in from our diagram. Here we're going to have Y over the sine of 35 is equal to 15 over the sine of 70. Rearranging, y equals 15 sine 35 over sine 70. I've just taken that and moved it up there, if you can see. And now I can type that into my calculator. So 15 sine 35 divided by sine 70. Now just make sure that you check your calculator is in degrees before the test or before your exam, so you don't get any disasters when you type in your trigonometric ratios. I've typed that in and I'm getting 9.16 as my answer. So y equals 9.16 centimeters. Okay. I'm using the emulated version of the Casio ClassWiz in this video. This is a great calculator, and if you're considering moving on to do A-level, I highly recommend that you purchase one of these. There's a link below in the description about it, or there's a card at the top now that you can click to find out more about the Casio ClassWiz. Question 24. The flight of a plane was in 2 stages. The table shows information about the flight. So the first stage of the journey, the distance travelled was 731 miles, the speed was x, and the time in hours was 731 over x. And then in the second stage, distance was 287, speed was x over x minus 24, and time was 287 over x minus 24. Okay. In total, the flight lasted 2 hours. Work out the value of x. Okay, so most of that table we don't need then, is it? The distance and the speed have been used to calculate the time. Time is equal to distance divided by speed. So you can see the first 2 numbers here and here just end up being here, and same with the second one. Okay, so they've just used kind of the DST triangle to work those out. So actually we don't need to know that bit at the beginning. All we need really is the last column of this table, this bit here. We know that the total, the flight time lasted 2 hours. So what we need to do is to say, well, I've got 731 over x, and I've got 287 over x minus 24. And I know that this is equal to 2 because it's 2 hours. Okay, so what we then need to do is work out what x is from that. So what we've done here is we've formed an equation in x, and this equation so what we've done here is we've formed an equation in x, and that equation involves some algebraic fractions that we're going to have to deal with. Okay. So first off, when you're adding fractions together, you need a common denominator. And we're going to form that common denominator by multiplying x and x minus 2 together. It's a bit like if you had like halves and thirds, then the common denominator would be 2 times 3, it would be 6, wouldn't it? So here I've got x and x minus 24, so the common denominator is x minus 24 in the same way. Okay, so how many times does x go into x times x minus 24? It goes in x minus 24 times. So I'm going to have to take that 731 and multiply it by x minus 24. And then that's going to be added on to, how many times does x minus 24 go into x lots of x minus 24 times? It goes in x times. So that's going to be 287x on the top. Okay. Now, if you find fractions algebraic fractions really difficult to follow, just write some fractions down and have a think about what you do with those. Algebra is just generalized arithmetic, so whatever you do with numbers, you just do the same thing with algebraic terms. So just try that out. All right, so then on the top here, I've got 731 lots of x minus 24. So I'm going to just multiply out that bracket there. So I'm going to get 731 lots of x minus, what's 731 times 24? 731 times 24, that's 17,544. 17,544, okay, and then plus 287 x, and that's all over x minus 24, okay, and that's equal to 2, okay. Now the next thing I'm going to do is I'm going to cross multiply this up here, okay, just multiplying through both sides with x minus 24. So that's 1018x minus 17544, and that is going to be equal to 2 lots of x minus 24, okay. So then I got to do some FOIL on the, well, then I've got to remove the brackets on the right hand side there, haven't I? So that's going to give me, on the right, I'm going to get 2x squared minus 48x. And on the right, I've still got 1018x minus 17,544. Okay. Now, I want to try and get everything on one side, and it makes sense to collect it on the right-hand side because that's where my 2x squared is positive. So I'm going to subtract 1018x. I'm going to add 17,544 to both sides. So these two things here are going to budge over to the other side, aren't they? They're both going to go over there. So that's going to give me 2x squared. And then I've got minus 48x, and I'm going to be taking away another 1018x. So 48 and 1018 together make 1066. So that's going to be minus 1066x. And then I've got plus 17544, and that's all equal to 0. So now I've got a quadratic, haven't I? Okay. Now notice I've got 2x at the beginning, so I can make things a little bit easier for myself just by dividing through by 2. So that's going to give me x squared minus, what's half of 1066? That's 533, isn't it? So 533x plus half of 17,544. 17,544 divided by 2, that comes out to be 8,772. And that's equal to 0. Okay. Right. So now, ideally, I'd like to be able to factorize this, but I've got a very big number there, haven't I? I've got 8772. So to break 8772 down into all its factor pairs, that's going to be a pain. But I really don't want to do the formula because that's even more of a pain. So how can I make this a little bit easier for myself? Well, I could express 8772 as a product of its prime factors, because I've got a key on my calculator that does that. So 8772 shift fact. So that's 2 squared times 3 times 17 times 43. 2 squared times 3 times 17 times 43. Now this gives me some factor pair choices then, doesn't it, that I can possibly make. So if for instance I picked that 17 in there, that looks about the right sort of size, and I did, well, what's 8772 divided by 17? Then that goes with 516. That's quite close, isn't it, to 533 I'm seeing in the middle. So I'm thinking that's probably my my best bet. So 17 times 516. So if I did 8772 and I wanted to know its factor pairs, then 17 goes with 516. I think that's going to be my choice. So it's positive on the end and negative in the middle. That means my brackets have both got a minus sign in them. One of them is going to be 17 and one is going to be 516. Just double check. Does that add up to 533? Yes, it does. So awesome. So x minus 17, x minus 516 seems to work. So then that tells me then, and that's equal to 0, so that means that x is equal to 17 or x is equal to 516. Now, do both those solutions actually work though? Now, if x is 17, if you have a look here, if you have a look at x minus 24, now if x was 17, then x minus 24 would be a negative number, which means our plane would be flying backwards, and that is not a good look for a plane. So I don't think this one is a possible solution. I'm going to say not possible, as x minus 24 is less than 0. Okay, so that one's that's not a possible solution. So the only solution is that one, x is 516. Therefore, x equals 516 what? Miles per hour. Okay, I am done. That was quite hard work. I've been given two functions of x. F of x equals x squared plus 1 and g of x equals x minus 5. I need to show that f of g of x is that expression there. Now, f of g of x means take g of x and put it inside f of x, which basically means wherever I see x in my f of x expression, like here, I need to replace it with that expression. So I'm going to take my x squared plus 1 and insert x minus 5 in where I see the x. Okay, and then I need to multiply that out, x minus 5 all squared. Now last time I did this, I did it the long way, but this time I'm going to use the identity. If I've got a minus b all squared, then that is a squared minus 2ab plus b squared. This is a very useful identity to remember. It makes multiplying out these things a lot quicker and easier. So that gives me x squared minus, so 2 times a times b in this case would be minus 10x plus 25 plus 1. So then just joining those last two things together gives me that. So, done. Now part B says solve fg of x equals gf of x. Okay, so we've already worked out what fg of x is. What's gf of x? So gf of x is equal to, well, we take our function of f of x and we feed it into our g of x. So this time round, our x is here and we're going to replace it with this expression. So that is going to sit where that is in there. So I'm going to get x squared plus 1, my x, take away 5, which is x squared minus 4, isn't it? Okay, now I need to solve fg of x equals gf of x. Now we just showed that fg of x is x squared minus 10x plus 26. So x squared minus 10x plus 26. And we now know that's the same thing as x squared minus 4. Okay, so our x squareds cancel, and we are left with minus 10x plus 26 equals minus 4. Okay, so I'm going to move the minus 10x to this side, and I'm going to move the minus 4 to this side. So that gives me 26 plus 4 is 30 equals 10x. So x equals 3.
Mr. T, he's the best, helps you ace every test. Maths worries now.